Hello everyone. In this lecture we are going to discuss about the principle of operation of single phase transformer. Okay, so all of you have heard about the transformer. Simply it is a static device which consists of two or more stationary electric circuits. Okay, as we have the figure over here, you can see in this circuit diagram. Okay, the figure at the arrangement of a simple transformer as shown over here. You can see that it is a static device and we have two stationary circuits, so one on the left side and another on the right hand side. All right. So transformer is a static device which consists of two or more stationary electric circuits, okay, interlinked by a common magnetic circuit, which is the what is the common magnetic circuit? This core is the common magnetic circuit which is connecting both of these circuits. All right. So by a common magnetic circuit for the purpose of transferring electrical energy between them. The main purpose of transformer is to transfer the electrical energy from between two circuits. All right. The transfer of energy from one circuit to another circuit takes place without the change in the frequency. There is no change in frequency. No frequency change. All right. And it is a static device. It is a static device. Okay, which consists of two electric circuits interlinked by a common magnetic circuit. Interlinked by a common magnetic circuits. Okay, there is a common magnetic circuit between them, whose purpose is to transfer electrical energy. Its main purpose is to transfer electrical energy, okay, between those two circuits. And already I have said there is no change in the frequency between them. Now you can see that, consider two coils, 1 and 2. You can see that T1 and T2. These are the two coils on the left hand side and the right hand side of this circuit. One on a simple magnetic circuit. This is a simple magnetic circuit. You can see that this is the core, is a simple magnetic circuit, and both of the coils are wound on this magnetic circuit. So these two coils are insulated from each other. ये दोनों coils एक दूसरे से insulated है. They are not in contact with them and there is no electrical connection between them. यहाँ आप देख सकते हैं, ये आपका coil यहाँ है, ठीक है, और ये आपका coil यहाँ पर है. इन दोनों के बीच में कोई इलेक्ट्रिकल कनेक्शन नहीं है. देयर इज नो इलेक्ट्रिकल कनेक्शन बिटवीन देम. सो लेट्स द T1 is the total number of turns on the input coil. You can see that this is the input coil and the output coil also. T1 is the number of turns over here in this coil and T2 is the number of turns on the coil number 2 respectively. Okay, so when the source of alternating voltage V1, this is the source of alternating voltage V1 on the left hand side, is applied to coil 1. जब हम इसको coil 1 पर applied करेंगे, an alternating current I naught flows into it. I naught is the current simply when there is no load is connected over there. Otherwise you can see that the supply current should be I1. I naught is the current if we consider when there is no load connected. This is the current being needed to magnetize this circuit. Okay, इस पूरे कोर को मैग्नेटाइज करने के लिए जो करंट यूज होता है वो I naught होता है, ठीक है. तो दिस ऑल्टरनेटिंग करंट प्रोड्यूसेस एन ऑल्टरनेटिंग फ्लक्स फाई एम. ये आपका फ्लक्स फाई एम प्रोड्यूस कर रहा है इन द मैग्नेटिक सर्किट. सो द आई नॉट इज द करंट प्रोड्यूसिंग फ्लक्स फाई एम, ऑलराइट, इन द मैग्नेटिक सर्किट. ओके, द मीन पाथ ऑफ दिस फ्लक्स इज शोन इन द फिगर. यू नो दैट जब ये करंट इसके अंदर फ्लो करेगा तो ये मैग्नेटाइज हो जाएगा कोल. ये कॉइल आपका मैग्नेटाइज हो जाएगा. जब ये कॉइल आपका मैग्नेटाइज हुआ तो अब इसमें इस कॉइल के अंदर आपका ये फ्लक्स फाई एम फ्लो कर रहा है एज यू कैन सी ओवर हियर. ओके, डॉटेड लाइन से जो शो कर रखा है आपको. दिस ऑल्टरनेटिंग फ्लक्स लिंक्स द टर्न्स T1. ये ऑल्टरनेटिंग फ्लक्स जो है आपका T1 टर्न्स को भी लिंक कर रहा है ऑफ कॉइल 1. ओके, coil 1 के, एंड इंड्यूसेस इन दैम एन ऑल्टरनेटिंग वोल्टेज E1, और ये इसके अंदर एक ऑल्टरनेटिंग वोल्टेज E1 इंड्यूस कर रहा है, ठीक है। E इज इक्वल्स टू सिंपली आपका होता है माइनस d∅/dt। जब कहीं भी चेंज इन फ्लक्स अकर करता है, आपका करंट फ्लो कर रहा है, उसकी वजह से फ्लक्स है, फ्लक्स जब चेंज हो रहा है, जब चेंज इन फ्लक्स डेवलप होगा तो उसकी वजह से आपका EMF डेवलप होगा, ठीक है। तो यहाँ पर आपका EMF प्रोड्यूस हो रहा है, दैट इज E1 बाई सेल्फ इंडक्शन, ऑलराइट, बाई सेल्फ इंडक्शन। दिस इज द मेन थिंग टू नो अबाउट बाई सेल्फ इंडक्शन, ऑलराइट। एंड द सेकेंड थिंग यू कैन सी दैट, ये तो आपका फ्लक्स E1 हो गया, जो कि यहाँ आपका फ्लक्स जो फ्लो कर रहा है इस कोर के अंदर, जिसकी वजह से E1 आपका EMF इंड्यूस कर रहा है। नाउ यू कैन सी दैट यही फ्लक्स आपका सेकेंडरी कॉइल की तरफ भी जा रहा है, मीन्स ऑन द टर्न T2, ये जो कॉइल आपका कनेक्टेड है यहाँ पर भी ये आपका फ्लक्स जा रहा है। तो आप जब जहाँ देख रहे हैं, जब ये फ्लक्स इस कॉइल से लिंक करेगा, तो जब ये फ्लक्स इस कॉइल से मीन्स सेकेंडरी कॉइल से लिंक करेगा, टच करेगा, तो यहाँ पर भी ये EMF प्रोड्यूस करेगा। तो दैट EMF E2 शुड ऑल्सो बी इक्वल्स टू N2 d∅/dt। ओके, ये चेंज इन फ्लक्स हो रहा है एंड द नंबर ऑफ टर्न्स, सॉरी देयर इज नो नंबर ऑफ टर्न्स, N2 नहीं है बल्कि T2, we have mentioned as T2. So T2 are the number of turns over here and the change in flux. So the multiplication of this will give you the EMF, that is the EMF produced on the secondary coils which are linking T2 number of the coils. Okay, ये what is this called? This is due to the self induction and this is due to the mutual induction. Mutual induction. All right. So these here you can see that यहाँ पर जब हमने वोल्टेज सप्लाई दी, नाउ हैव अ ब्रीफ लुक ओवर हियर। जब आप ये सब एक मिनट, फर्स्ट ऑफ ऑल वी रब ऑल दीज थिंग्स। नाउ जब आप यहाँ पर सप्लाई देंगे, AC सप्लाई आपने दी, जब AC सप्लाई आप देंगे तो इसके अंदर करंट फ्लो करेगा, दैट करंट विल फ्लो इन दिस कॉइल। जब ये इस कॉइल के अंदर जब ये करंट फ्लो करेगा तो इसमें फ्लक्स डेवलप होगा, ये फ्लक्स डेवलप होगा तो दिस इज द मैग्नेटिक सर्किट, ये इससे लिंक होगा। तो इस मैग्नेटिक सर्किट के अंदर ये फ्लक्स आपका मूव कर रहा है φm, ठीक है। जब ये फ्लक्स आपका इसके अंदर मूव कर रहा है तो यू कैन सी दैट जब फ्लक्स मूव करेगा एंड देयर इज अ चेंज इन फ्लक्स, तो दैट चेंज इन फ्लक्स विल डेफिनेटली प्रोड्यूस द EMF in this primary coil, okay, due to T1 number of turns. All right. अब and due to the self induction, as we have already told this, now the same flux is linked to the secondary coil. ये secondary coil से भी टच कर रहा है आपका। जब ये flux आपका secondary coil से लिंक करेगा, then you can see that that flux which is linking to this secondary coil and the number of turns are T2, it will definitely produce the EMF E2, okay, depending upon the number of turns and the change in flux, and that EMF, the secondary EMF, will go on the load side. All right, so this is the simple working principle of the transformer, and this transformer can be of two types, that is you can see that it can be a step up transformer, a step up transformer and step down transformer. Okay, what is step up and step down transformer? Step up and step down transformer is simply this, that when the number of turns T1 is less than number of turns T2, all right, this is the step up transformer. Means if you are supplying 110 voltage on the primary side and the number of turns on the secondary side is twice of that, it will definitely give 220 volts on the secondary side. All right. Similarly, this is a step up transformer, that is the number of turns on the primary side should be greater than the number of turns on the secondary side. So if you are supplying 110 volts on the primary side, you will definitely get 55 volt on the secondary side. All right. So this is the thing, the step up and the step up down transformer. The transformer simply the transfer the voltage, it is giving the supply from primary to secondary depending on the number of turns. All right. And similarly, ये वोल्टेज तो आपका यहाँ डबल हो रहा है और यहाँ स्टेप डाउन है तो हाफ हो रहा है, एज यू कैन सी दैट, बट द करंट जो होगा वो इसी तरीके से आपका इन द रेसिप्रोकल ऑफ दैट चेंज होगा। मीन्स अगर प्राइमरी साइड पे आपका करंट 2 एम्पियर था तो ये आपका वोल्टेज तो डबल हो रहा है, करंट आपका 1 एम्पियर हो जाएगा, ऑलराइट। और यहाँ पर अगर आपका 2 एम्पियर था, ठीक है, तो 2 एम्पियर करंट अगर आपका प्राइमरी साइड पे था और वोल्टेज आधा हो रहा है, हाफ हो रहा है, बट करंट गेट ट्वाइस ऑफ दैट, ये 4 एम्पियर हो जाएगा, ठीक है। तो सिमिलरली द पावर रिमेन्स कांस्टेंट ऑन बोथ द साइड, V into I on the primary side should be equals to V into I on the secondary side, V1 I1 should be equals to V2 I2, all right. So this is the thing which we will discuss further, all right. So this is the simple working of the transformer, and now we are going to drive the EMF equation of this, the electromagnetic field equation of the transformer. So let us see that, let us consider the flux over here. Let the flux at any instant is given by at any instant is given by phi. Phi is equals to what? Phi m sin omega t. Okay. Since we have the sinusoidal voltage, it will produce a sinusoidal current, and similarly there should be the sinusoidal flux, all right. So the flux equation should be given by this, phi equals to phi m sin omega t. Now the instantaneous EMF induced in coil of t turns, instantaneous EMF induced in a coil of t turns linked by this flux, okay, given by Faraday law. Faraday law. Now what Faraday law states that? Faraday law states that EMF should be equals to minus d over dt into the flux and the number of turns, all right. The number of turns into the flux, the change in the flux produces the EMF. We have already learned this Faraday law of electromagnetic induction, and negative sign is due to that the source, due to the Lenz's law, because it opposes the source which produces it. Due to the Lenz's law, the negative sign is due to the Lenz's law, all right. Lenz's law states that it opposes the source which produces it. So let's move further. This will become minus t, t is simply constant, d over dt phi, all right, and minus t d over dt phi. Phi is simply given by over here, phi is equals to phi m sin omega t, okay. To differentiate that, we will get omega phi m sin should be becomes cos omega t, all right. So we got this. Let's make some changes in this, then you will see that it will give us t omega phi m sin, when we change cos omega t, and the negative sign is also here, ठीक है. तो negative minus of cos omega t, that will give omega t minus pi by 2, means omega t minus 90 degree, all right. So we got this, and let's move further. This equation may be written as EM sine omega t minus pi by 2, okay, where Em is equals to t omega phi m. Understand? So this is so easy over here. Now let's revise some previous things. You must remember all those things. For sinusoidal wave, for sine wave, okay, RMS value of EMF is given by RMS, root mean square value. You all must remember all these things. RMS value of EMF is given by ERMS should be equals to divided by E, which will be equals to EM, maximum value, divided by root 2. All right, you must remember this. So this E, you know, this was EM over here. E will be equals to EM upon root 2. Okay, EM upon root 2. We are getting EM from here. This will give T omega phi m upon root 2. All right. T, you must know the value of omega. Omega is given by 2 pi f into phi m upon under root 2. This will give root 2 t pi f into phi m, and we all know the value of pi and root 2. When we are simply going to multiply the root 2 with the value of pi 3.14, we are going to get 4.44 phi m into frequency into the number of turns. So this is what the equation of EMF we got over here. So this is called the EMF equation of the transformer. EMF equation of the transformer. All right, now one more thing. Since we all know that we have the number of turns on the primary side is T1 and the number of turns on the secondary side is T2. So the EMF on the primary side, that is simply denoted by E1, that should become equals to 4.44 phi m. Now in the frequency, number of turns on the primary side is T1. Okay, so this is T1, and E2, the EMF on the secondary side, it will be equals to 4.44. Simply the frequency should be same, flux should be same because the mutual flux was there, and the frequency should be same, as we have already understood that, and the number of turns should be T2. All right, so this is E1 on the primary side, this is E2 on the secondary side. So this is the EMF equation on the primary side and on the secondary side, in which phi m is the flux, maximum flux. Okay, whose unit is Weber, frequency as we all know in hertz, and E1 and E2 should be in volts. Number of turns should be given by some constant value. All right, so this is the EMF equation of the transformer. So today we have discussed in this lecture the working principle of the transformer and the EMF equation of the transformer. All right, thank you, thanks a lot.